Hello, my name is Tate Williams, and I am doing a presentation on baseball box score statistics and their correlation to WAR. I did this using Python, Jupyter Notebook, and this is for my sports analytics Python class. This is my final project. So before I did anything, I imported a lot of things. First thing is making sure I'm able to present multiple inputs. So I did that using an interactive shell. Then from PyBaseball, I imported batting and pitching stats, and then also layman just in case. Imported NumPy and Pandas, and then lastly I imported a matplot library, PyPlot, as well as Seaborn. So first of all, I'm using statistics from the 2018 through 2022 baseball MLB seasons. So first of all, I grabbed that data from those years, and I set them into pitching data. I later changed it so that all I got were common box score statistics, so nothing too advanced. So you'll see in this graphic right here, we have WAR, but we also have ERA, games started, saves if they were a relief pitcher, the innings pitched, hits, runs, earned runs given up, home runs, walks, hit by pitches, strikeouts, and some others as well that aren't visible here. So with all of those statistics, I thought it would be best to categorize them based on different types of stats. So I made 4 different data frames. One that uses wins and saves as the main 2 statistics there. I've also got one with games and innings. It's also got like complete games and shutouts, just some extra stats there. I've got one with ERA that involves like hits and homers, runs and earned runs, and then lastly I have a strikeouts one that also has walks and hit by pitches. So I created a matrix plot for each of these categories, and I kind of went through a little gauntlet. As you can see on the far left of each of these plots, we have their correlation to WAR, and obviously you want correlation as close to 1 as possible to mean that it's the strongest positively correlated. And so I pretty much disregarded any of the metrics that did not have a strong positive correlation. So in these, it may be difficult to visualize or see, but I grabbed in this first plot to the far left, I kept games started, and innings pitched, as they're very positively correlated over here. Complete games and shutouts were not that strong. I also, for the next plot, I kept wins because they seem to be pretty positively correlated to WAR. In this next one, I didn't keep any of these, and I almost considered keeping ERA because obviously as a pitcher, the lower your ERA, the better you're pitching basically, the less runs you're giving up on an average 9-inning game. And so I almost considered keeping it, and I later checked and found out that it was still not the most correlated. So then I also grabbed on this last one strikeouts because it was the most correlated of that group. So I created a new data frame with these given metrics that I collected. So wins, games started, inning pitched, and strikeouts. And it should be the same data frame, but just those as well as the names. I thought that would be good to include still. And lastly, I did the correlation matrix. And I also had a visualization too to just see if it was going to be blatantly obvious. And it seemed as if the wins and underneath at the very bottom strikeouts were the most correlated. And it turns out they were the 2 most correlated, but strikeouts were very much so the most correlated. 77.83% correlated to WAR, which was the most among these statistics. And it was the most among all the statistics that I had gathered at the beginning as well. So I did the same thing with batting data as well. Grabbed a lot of common box score statistics for hitters, So we have games, at bats, plate appearances, hits, and then each of the different hits, singles through home runs. There are runs, RBIs, walks, strikeouts, hit by pitches, stolen bases. And then I thought I would include this too, average on base percentage, slugging, and then OPS, which I think if OPS were the top one, I might just include which one of these was the strongest, because this is a combination of both of these. So I did the same thing. I changed these into different categories. I did 4 as well. So we have a batter, ball, and play, which is the hits, hits, singles, doubles, triples, homers. Whoops. I also have one for games. So this is just like the amount of games, the amount of at-bats, plate appearances, the amount of runs, and also the amount of RBIs. Averages includes those 4 metrics, the average, on base percentage, slugging, and OPS. And then I have a non-ball and play, which is strikeouts, walks, hit by pitches, and stolen bases. So again, I created different matrix plots to see their visualization correlated using regression. And I gathered a few more metrics than I did from the pitcher data, because it seemed like most of these were pretty strongly correlated. And so in this first one, it has the games and the at-bats and the rest of those, the runs and RBIs, did seem to be slightly more correlated, but all 5 of these were positively correlated. I then, out of this one, it looked like on-base percentage and OPS were the most correlated in this group out of these. In this third plot, hits and home runs seemed to be the most correlated. Seemed like doubles were pretty correlated as well, but I just decided to take hits. It does seem like there is a slightly more positive correlation to WAR. And then in this last one, it seemed like walks were the clear favorite. And so I did the same thing as I did with the pitching data, and I created a new data frame with those metrics. And then lastly, I created a correlation matrix. And so you can see visually, it seemed like everything was pretty close. However, runs were very strongly correlated, as well as OPS too. And hits were pretty high as well. And it turned out that runs were actually the most correlated to WAR in the last 5 years, which I found really surprising and interesting. Right behind that was OPS, but runs at 71.44% was the most in the last 5 years. And speaking of the last 5 years, I thought it would be interesting to compare this to different years, and so I decided to use all data collected before the year 2000 for all baseball. And so on this right plot right here, we have that correlation matrix with all the statistics that I had gathered in that first pitching data frame. And as you can see by the numbers, strikeouts just edge it out, 69.71%, and wins were not that far behind, so 68.09% were correlated to WAR with wins, which I thought was very interesting. It seemed like strikeouts were definitely the clear favorite. And so the more strikeouts you have, the better chance of having a higher WAR as a MLB pitcher. However, it was different when it came to offensive stats. Runs, as we saw earlier, was 71%, but it's dropped down to 64% from the previous, or in this 1871 to 2000 data. And it looks like OPS was the clear favorite at 73%. But as I said earlier, I said I would take which of these higher on base percentage or slugging, since they are, added together to create that OPS metric. And so just slightly on base percentage wins in this scenario, which I think is very interesting, because right after the year 2000 came the time of Moneyball, when they pretty much abused on base percentage as a clear way to run a baseball team. And it was I just think that it's interesting that they probably used a lot of this data to see which players are the best players, and it seemed like the players with the highest on base percentage were the best players in baseball. Um, I found this really interesting, and I look forward to hearing and watching the presentations of the rest of the class. So thank you.